Hello, welcome to ZTalk. In last session, we talked about elk stack and we test out deployment and configuration of elasticsearch, logstash, Kibana, and metric beat on top of a EC2 instance manually, right? Here's the link to review what we have accomplished so far. Feel free to drop over there. Just try to refresh your mind and get ready for this session. Cool. All right. Moving forward, for this session, as per our plan, I think it's time to figure out how do we automate this whole manual process via Terraform, right? What's more, as we know, in any real-world production environments, we better get access Kibana or whatever interface via DNS instead of just IP and port, right? Remember in our previous session, we logged on Kibana interface via the IP of that EC2 instance, followed by the default port of Kibana, which is 5601. That's definitely not a good idea for any case for our real environments, right? We've got to configure DNS for that. So for doing that, we're going to talk about a DNS service called Route 53 provided by AWS. And more heads up about today's demo. We're going to run into some challenges while we configure record for Kibana on Route 53 shortly. I'll give you my solution first. Basically, that issue or that challenge is, when we configure Route 53 record, the default port is 80, right? HTTP port 80. However, as we know, the default port of our Kibana service or Kibana interface is 5601. So how do we set Route 53 record on a different port? That's the challenge I'm talking about. So I'll give you my solution first. My solution is that I'm going to utilize Nginx as a reverse proxy. As a heads up, I just want to bring it up, these 3 key points that will be covered in this session ahead of time, so you get prepared. All right? Again, firstly, we're gonna deploy elk stack via Terraform, and then we're gonna try to configure Route 53 DNS, and also try to automate this configuration via Terraform as well, right? The last but not least, we're gonna try to configure Nginx as reverse proxy to fix that port issue for our Kibana service or interface. All right, cool. So firstly, what is Route 53? AWS Route 53 is a scalable and highly available DNS service. 53 is a reference to the TCP UDP port 53, as we know, where DNS server requests are addressed. All right. In addition to being able to route users to various AWS services, including EC2 instance for sure, right? Route 53 also enables AWS customers to route users to non-AWS infrastructure and to monitor the health of their application and their endpoints. All right. Here I list out 4 common record types that can be when we configure Route 53. If you want to learn detail about different types of records, just Google it. There are a lot of good explanations out there. I will explain like a little detail for the first 2. Let me start with A record. So the A record maps a name to a specific IP, like what I'm going to demo, to use my domain to point to the EC2 instance that we spin up earlier for hosting elk stack. That's a good example or good use case of a record. On the other hand, the CNAME record maps a name to another name instead of an IP. CNAME records are typically used to map a subdomain to the domain hosting the subdomain's content. I attach a simple example here. As you can see, in this example, the blog.example.com points to example.com, which is like a CNAME record type. All right, and assuming example.com is based on a record, an IP address, so we know that this blog.example.com eventually resolves to that IP address. Right? That's basically the relationship or the difference between a record and the CNAME record. Right? Cool. Nginx reverse proxy. I guess these probably the most common use case of Nginx. So basically, Nginx follow these, refer to these diagram. Nginx acts as reverse proxy to retrieve resources on behalf of clients, and these resources are then returned to the client, appearing as if they are originated from the reverse proxy server itself. That's basically Nginx, reverse proxy all about. All right. Cool. Demo time. So in this demo, I'm gonna again follow the 3 key points: set up ELK stack via Terraform, configure Route 53, and then automate it via Terraform as well. And then we're gonna also cover the configuration of reverse proxy on Nginx. That's pretty much it. Before I jump to the demo, remember thumb up if you think this video is useful, and subscribe my channel if you haven't done that. And most importantly, leave comments if you have any questions. I will try to get back to any of your questions as long as I know it. All right. Cool. Let me jump to my Visual Studio Code to talk about Terraform. All right. By the way, one more perhaps for this demo. If you also want to play it out on your end, you're gonna need a domain. So I purchased a domain on GoDaddy, domain manager. So basically, my domain is zztalks.xyz. This is my domain name that I just purchased. It's just $1 per year. It's cheap, right? If you want to do that on AWS on Route 53, so just click Route 53 and you can purchase domain by domain registration. You click register domain. You can do that too, but it's kind of more costly. As you can see here, you can choose a domain name, but you see it's kind of pricey. $12 compares mine, which was $1 per year, right? So either way, you can do over here, and you can purchase a testing domain anywhere else, right? It's up to you. But for testing configuration of Route 53, you're gonna need a domain like this. All right, cool. Let's jump to Terraform. All right, let's firstly take a look at these create instance that Terraform. Compare with the one that I created in the last session. This time I did not use the AWS module for spin up EC2 instance because I wanted to refer the old code base that I created in the previous session, specifically this section, those provisioners. If you have been learning with me from the beginning, I believe those provisioners should look familiar to you as well, because we have used those provisioners before. Remember, we had a session for spin up EC2 instance and install Nginx on top of that, and we used those provisioners in that session. All right. So basic, we're gonna do the same thing. This is the key difference with the previous session. The others look similar. So you see the security group. We still have to create a security group and make sure all those ports for ELK stacks are open, like elasticsearch, 9200, Kibana, 5601, and log-stash, etc. Right? Of course, we need to make sure port 22 is open as well, because we're gonna need to SSH to that EC2 instance once it's spin up. So moving to the key section for creating EC2 instance down here, I just hard coding the AMI and instance type. It's still gonna be a Ubuntu instance for the AMI right here, and talk about those provisioners. So basically, the file provisioners. So basically, what it does is just copy the file from your local to the remote host, which is the EC2 instance we're gonna spin up shortly. Remember, back to the previous session when we did manually. We can, before we start those ELK services like Kibana, log-stash, we did some modification in the configuration file, right? Kibana.yaml, for example, I just copy that Kibana configuration file down here inside of the same folder. Remember, what we did was just uncomment the ports. So we're still going to use the default port 5601, and the server host, I changed it to 0.0.0.0 to allow connections from remote users, right? And at line 32, I include or add the URL to hook up with elasticsearch, right? Because it's running on the same host, so it's just localhost and 9200. That's pretty much what we did, or what we modified in the Kibana.yaml. Same thing when we configure log-stash. I created a example template for parsing Apache logs. Here, remember the 3 steps, input, 3 sections, input, filter, output. Here, I just made up a hypothetical path to the Apache log, and then we did the filter to instruct the log-stash agent to format the log as the way we want, and then we output the formatted log to elasticsearch, something like that, and then we restart log-stash with these templates, right? That's exactly what we did in the previous session manually, right? Here, I put these configuration file in the same directory as along with the Kibana.yaml. And one more thing, install elk.sh. So I created a shell script. Basically, this shell script contains all the steps or all the command we issued when we did it manually. See here, remember once that Ubuntu EC2 instance was up and running, firstly we did some prep work, right? We did upgrade of the package, and then we install Java JRE and make sure the Java version qualifies the requirement of ELK stack, right? And then we install elk stack component one by one. Start from elasticsearch, and then logstash, Kibana, and metric beats, right? So that's pretty much what we did manually, and I put all the steps right here. So once we got these shell script ready, the next step back to the create instance. Well, what we need, we use those the remote exact provisioners. Basically, these provisioner does is to revoke the shell script on the remote server on that EC2 instance that we're gonna spin up, and to run, give the execute permission, and then run this shell script. And the previous three file provisioners, basically it just copy the file that I created right here in my local, and copy those files to the remote host, which is again the EC2 instance that we're gonna spin up. That's pretty much it, and move forward. So because I did not use the module, so I'm just gonna use the default VPC in that region. We're still gonna spin it up or host it in the US East 2 region. Excuse me. And I assign a elastic IP to this EC2 instance, and then gonna output that public IPs. That's pretty much all it does in for this script. And now let's move to Route 53. Before as you can see, I already created a separate configuration file for Route 53, but I want to show you quickly the configuration. So for this session, I just want to go through the basic configuration of Route 53. And here I'm on the AWS console and go to Route 53. So what we're gonna do in this session, so firstly, we're gonna create a hosted zone. Because remember, so as a prerequisite, you have to have a domain if you wanna test on your end. Like for me, I just purchased a domain on GoDaddy, so I'm gonna use this domain as the demo. So because I already have the domain ready, and I don't have to do the register domain or purchase domain on AWS because it's more costly, like I explained just now. And so what you need to do if you do it manually, so you just need to click create a hosted zone, and then you put the domain like here, copy and put a domain name right here, and the rest is the same. Just click create hosted zone. Right, so the zone was created successfully, and as you can see, there already were two records being created, and these name servers, this is another thing, or we're gonna modify on our domain side. We need to modify the name servers. So once we finish up using Terraform, once that Terraform done, it's gonna output the name server, right? So that's basically gonna be the same thing like here. So I'll show you shortly. So when we run Terraform. So the next step, we're gonna need to create a record, right? So here, click create record, and this is the place where you're gonna for our Kibana configuration. So I will give the record name as elk, right? And again, so for the record type, we're gonna use a type, right? So remember in the PPT session, so a type is just mapped to a specific IP. That's exactly the same use case as we're doing right now. We're gonna spin up an EC2 instance to host our elk stack, right? So here, that's where we're gonna copy and paste the IP of that EC2 instance right here. So because right now there's no EC2 instance running yet, but that's the place if you do it manually. That's the place once the EC2 instance is up and running, copy that IP and paste over there, and then click create record. Then you're done. All right, cool. So that's like it's simple as it is. So let's figure out how do we automate this process on Terraform. So let me quickly delete this zone, because we're gonna do the same thing via Terraform real quick. Jump back to my Visual Studio Code, and here we go, the Route 53. As you can see, I used two resources. Firstly, as mentioned, we need to create a zone, right? Here I call it zztalks.xyz. That's exactly the domain name I purchased on GoDaddy. zztalks.xyz, right? And then next step, once the zone is created, we need to create a Route 53 record, right? So here I'm using that zone we just created in the first step, right? Zone ID, AWS Route 53 zone, and zztalks zone ID, and we're gonna give the name of that record as elk.zztalks.xyz. And we're gonna use a record as the type of the record. That's exactly the same thing what I showed in the AWS console, right? And the last step, we need to copy and paste the IP of the EC2 instance. That's the place where we're gonna do that. So here, back to the create instance, I assigned a elastic IP to the EC2 instance right here. That this is our EC2 instance, right? I assigned a elastic IP to this instance. That's where we're gonna call here. So AWS EIP and IP and public IP. So so it's gonna copy that EIP and paste in the record, right? And last but not least, output name server. So that's exactly what I showed back to the console. So there, once we create a zone, there were 4 name servers created. So here is same thing. I want to list them out in the console once the Terraform deployment is done. So basically, we're gonna need those name servers to update on the domain side, on the GoDaddy, so that on my domain side. Remember, that's basically the procedure. And for name server, if you're not familiar with name server, so basically a name server refers to the server components of the DNS. It's designed to translate domain names into IP addresses, and it handles queries from clients about the location of a domain name and its services on the DNS server. So when you purchase the domain, out of box it has a default name servers. But here, because we are using Route 53, the service provided by AWS, we need to update the name server with the one AWS provides. That's basically why we need those name servers information. All right, that's pretty much it. So I think let's go kick off the Terraform apply and verify firstly if all those elk stack app components or install successfully on the EC2 instance, and then we go from there. All right, cool. All right, jump to the terminal. Let's kick off Terraform. Let's first issue Terraform plan to make sure there is no syntax error out there. All right, look good. As you can see, there will be 6 resources being created, and I will issue Terraform apply. it's gonna take a while because that shell script is gonna install elk stack at runtime, and while you play or test it out on your end, please keep an eye on those output in terminal. Just make sure if something goes wrong, you know where the issue was, and it will be easier to identify and locate in your scripts. All right, so let's be a little bit patient and wait for it. All right. Okay, one more thing, by the way. So this is definitely not the only way to automate this process. Remember, we had a session to talk about Pucker. So the right way, so once we test it out and get it ready, so we can build a custom MI that contains all the elk stack, elk services, all the software we need, and build a custom image. So next time we just use that image instead of running those installation at runtime. That's the way to go. But for here, this session, I want to do these at runtime because it's kind of more flexible, because once we test it out working, so I need to explain, we need to continue to configure Nginx, right? So to make sure we are able to get access the Kibana interface via those DNS. Because right now, with these configuration, once it's done, those elk stacks should be installed successfully, but we're still gonna have issues when we're trying to access via the DNS. So we should still be able to get access via port, IP address, and port, but there are still steps missing for us to be able to get access elk interface through DNS. So we will see what the issue will be. So and we will update going forward, right? So let's focus on these steps first to make sure or that shell script works as expected, and all the components, elasticsearch, Kibana, Logstash, metric beats are installed successfully. That's the first thing we need to make sure. All right, cool. All right, Terraform is done. As you can see here, all green. Apply was completed successfully. There were 6 resources added, and here we go. Those were the outputs that we configured. Firstly, name server, right? We wanted to list out all the name servers so that we can grab it and update on the domains. For me, it's GoDaddy, right? Domain side, we need to update the name server, right? And the second was the public IP. That was the elastic IP that was assigned to that EC2 instance. All right. So let's do some verification on the AWS console side. Firstly, Route 53. So as you can see, there was one hosted zone created. So click it, and this was the domain name that I purchased on GoDaddy. So zztalks.xyz, exactly same like what we did manually before we moved to Terraform, right? And another thing, there was a record whose type is a record was created for elk, right? And as you can see, elk zztalk.xyz, this record maps the port. Map the IP of that EC2 instance right here. All right, cool. Jump to EC2 instance. Let's log in and verify all those services are up and running as expected. So I'm gonna grab these elastic IP, and go to my terminal, and I will do SSH, Ubuntu, and private key, right? So do a sudo su to get root access, and then let's check out the service one by one. Service elasticsearch, status, here we go, and active and running, look good. And next one, Kibana, active and running. And next one, metric beat, active and running. And the last one is logs-dash. All right, look good. And let's cancel it out. And one more verification to make sure the indexes were created like we did manually. So as of now, we still should be able to get access the Kibana interface via IP and port. So let's copy the port, open the browser, 5601. Here we go, and we were still able to get access Kibana interface, right? Explore, under management, stack management, and index management. And as you can see, there were two indices, metric beat and logs-dash were created. And for the metric beat, there were already documents feeding to Elasticsearch right here. Cool. Look good. Now let's move to the next step. Go back to Route 53. Because the goal is to use DNS to get access Kibana, right? Instead of the IP and port, we're expecting to use this record name elk.zztalks.xyz to get access Kibana. But we still have problem like here, right? With current configuration, it says these sites cannot be reached. That's because we haven't configured Nginx or reverse proxy. Because go back here in the records, as you can see, if you noticed, when we map the records to the IP address, there's no port mapping, because in general DNS does not care about ports, right? That's why we need to configure Nginx to handle virtual hosts with a proxy, a reverse proxy to Kibana, such that all requests would still hit port 80, like here, but they get handled and they get handled and routed to port 5601. That's basically what Nginx is responsible for, right? And now I guess you understand why we need Nginx for this use case, and I'll show you how do we configure reverse proxy on top of Nginx. But first, let's do that again manually, and we need to install Nginx on that EC2 instance. And then once we install Nginx, we test it out, or reverse proxy configuration to make sure it works, and then we move to the automation to integrate with our existing Terraform configuration, so it's part of the automation. Yeah, that's the deal, and it's happening the way we were testing right? So cool. So let me jump back to my terminal, and on that EC2 instance, I'm already on, right? So the next step, let's install Nginx on this EC2 instance. So apt-get install Nginx -y. Yes. All right. So let's wait the install is done, and then I will explain how do we configure reverse proxy. It's pretty straightforward, right? Oh, all right. So it's already finished. So let's go to the configuration folder of Nginx. It's under /etc Nginx here. There are a bunch of configuration files, and what we need to do, we need to create a configuration under sites available. So as you can see right now, it's just contain the default file, right? So we're gonna need to create a new configuration file, and for our domain that that domain that I purchased on GoDaddy. Let me show you how do we do that. Here is the configuration. It's pretty simple. I create a file in my Terraform folder, right? Because we're gonna use it when we automate these process. Along with other configurations, right? We need to update, once we make sure these script works, we need to integrate with the existing create instance. We need another provisioner file to copy these configuration to the EC2 instance and recycle Nginx, right? So let's verify it works first. So here, if you haven't configured reverse proxy before, you can also refer to the one here. So go to /etc Nginx, you go to the sites available, and there is a default configuration. You can refer to these default configuration file. It has comments about the explanation of each step. So you can refer the syntax right here and create your own, right? That's basically what I did. And now let me create a configuration inside of the sites available folder. So /zztalks.xyz, right? And copy these configuration. So here, let me explain a little bit. It's pretty straightforward. So I'm still gonna lesson port 80, right? But I'm routing the traffic through port 80 to these localhost 5601. That's the Kibana interface, right? So the server name is elk.zztalks.xyz. That's the A record that we created for this map, right? That's pretty much it. So let's copy this and paste it right here. All right, and save it. Okay, and what's next? We can do a Nginx -t, to check if there are any syntax error in our configuration. And as you can see here, what it returned, syntax is okay, and test is successful, right? So now we can move forward. And next step, we need to enable. We create a configuration, but we haven't enabled it. That's why you can see. Let me go back to the parent folder. Here, along with size available, there's another folder called size enabled. So we need to enable this new configuration. For enabling, we just need to create a sublink, right? So this is how we're gonna do that. We're gonna jump back to the available folder, and then we're gonna create a sublink to link these new configuration to the sites enable folder. Right, hit enter, and now let's go to sites enable folder, and you should be able to see a sublink created right here. Right, that's pretty much it. Then the last step, we need to recycle Nginx. So let's recycle Nginx by service Nginx restart. All right, so now let's check the status of Nginx. Okay, active running. The restart was successful, and you can see the restart happened 6 seconds ago. So all look good. Cool. Now let's go back to the AWS portal. Then we need to update the name server, right? We haven't done that yet. So here we go. Those are the name servers we need to update on the domain manager or on the GoDaddy side for me. So let me grab the here, and let's go to here. Go to your domain that you just purchased. If you also test it out using domain GoDaddy. So click Manage DNS. Here, as you can see, those are the name servers, right? We need to update the name server. Let me go here, click Change, and let's update one by one. Let me take it out. And that's 8.16, and the other one is 420. Take the dot here and one 1117, and last one 1800. All right, so save it. And change name server is risky and could potentially lead to your website disappear. Okay, just yes, check yes and continue. All right, so just give a little bit of time to wait for these change being applied, and then now let's move back to the AWS console, and here let's see if it works. Oops, it's still showing this size can't be reached. So what's wrong? Now let's check our current configuration. Remember, we're still less than port 80 right here, right? But however, check the create instance or Terraform configuration. We need to update our security group right here. So here the port 80, the HTTP ports was not open, right? We only open port of those ELK stack ports and SSH, right? So here we need to add a new policy to ensure that port 80 is open as well. So here, let me do it manually first. So go to EC2 instance. and here, right, click security group, and this is the one we create here. Again, so when you do Terraform, you need to automate this process, not manually. That's not the way to do it. You have to, everything you have to do this through the script, not manually change it. Otherwise, it's gonna break Terraform, right? But here, I'll just show you what has to be done to make sure it works. Then we move to automation. Edit inbound rules. And here we need to add a role, custom TCP, and the port is 80, right? And we'll give it 000 like this, and save rules. Cool. Now let's try it out one more time. Oops, it's still showing zztalks.xyz. This site cannot be reached. Let's give a little bit time. Maybe that name server was not updated just yet. Let's give a little bit time. All right, here we go. As you can see now, I was able to get access through the DNS right here, right? So here, hit enter. Right, it was the update. So once you update the name server on your domain, so it takes some time. For me, it wait like a minute or so. So to wait for the update was applied, it takes some time basically. Now I'm able to get access the Kibana interface via this DNS name. Now what we can do to remove the port 5601, go back to the security group, and inside of the security group, I already did that. So right, I take the 5601 port out, so we don't need to get access the Kibana interface through that port. We're gonna use this DNS. The traffic will hit port 80, and then it will route to our Kibana interface, port 5601. Now, that's pretty much it. Okay, cool. Since it's working manually, let's jump back to Visual Studio Code, and let's figure out how do we automate this process. So it's pretty easy. Again, I already had that reverse proxy configuration right here. You're gonna need that to put here, and let's modify or create instance right here. So in this case, you don't need these ingress, this port anymore. You can take it out, right? And besides that, we're gonna need to add update the security group to make sure port 80 is open, right? To enable HTTP 80 port. And same thing, I'm gonna do an ingress from port equals 80 and to port equals to 80 as well. And protocol is TCP, and CIDR block is also same thing right here. I just copy this guy here, and all right, that's the port. We need to make sure it's open, and the next things is back to the key section provisioners. We need another provisioner to before the remote exec. We need to add another provisioner to make sure that configuration, this guy, I'll take it out. zztalks.xyz, is there in being copied to the EC2 instance. zztalks.xyz. All right, that's it. So last but not least, update the shell script to include the step for installing Nginx, right? Install Nginx. So I will grab that those commands I issued just now over here. So firstly, we use the package manager to install Nginx, right? And then we configure that configuration file, zztalks.xyz, and put it under sites available folder, right? And then we need to enable this new configuration by creating a sublink to the enable folder. And the last step, we recycle Nginx. That's what we did manually, right? All right, that's pretty much it. So once you update it and just issue Terraform, you can do a Terraform destroy. Remember, if you follow my step, you test it out manually, you need to remove those modifications, like your security group, remove and back to what it was, right? And you can do a Terraform destroy and redo the apply to test it out. Or if you do the reply, you have to update the name server again, right, with the new created EC2 instance. Otherwise, just run that Terraform apply. It should work. So basically, that's pretty much it. Hopefully, it helps you one way or another. You should be able to bring up EC2 instance, install ELK via Terraform, and we used to get like a base understanding how to use Route 53 to configure DNS and reverse proxy on Nginx for this session. That's the goal, right? All right. That's let's call it a day. That's pretty much what I want to cover in this session. Thanks for watching, and again, leave comments if you have any questions. I will answer as soon as possible. Right? Cool. Thanks again, and I'll see you next week.
Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.